Okay, so I'm in the lesson 2.2 packet, all right, the packet with the Pythagorean theorem. So what I need you to do is go to page 8. All right, so open up to page 8, and I'm going to give you some notes that I think you'll be able to fill in this margin here, okay? So remember when we classify triangles according to their side lengths or their angle measures. So when we classify triangles according to their side lengths, we could classify them as scalene, where no sides were congruent, isosceles, where 2 sides were congruent, or equilateral, where all 3 sides were congruent. According to angle measure classifications, we could classify them as obtuse, acute, or right. An obtuse triangle is a triangle that has one angle measure that's greater than 90 degrees. An acute triangle is a triangle that has all 3 angle measures less than 90 degrees. And a right triangle, these are what we've been studying, is a triangle where one angle is equal to 90 degrees. So before right now, we haven't been able to classify angle measures if we've only been given 3 side lengths. Okay, so if I look at this triangle, I know right away that it's scalene because no sides are the same, but I can't say for sure whether it's an obtuse, acute, or right triangle. So we would just say that our drawing is not to scale. Okay, so now let's talk about how we can do this. So if we have 3 side lengths, we'll call them A, B, and C. And what we're going to do is compare that value of C squared to A squared plus B squared. So think about what we know, C from the Pythagorean theorem, it's always the largest value. It's the biggest number because it represents the longest side length in the triangle. So a triangle is obtuse if C squared is bigger than A squared plus B squared. A triangle is acute if C squared is less than A squared plus B squared. And a triangle is a right triangle if C squared equals A squared plus B squared. And it's not coincidental that this is what our Pythagorean theorem is. So for each of the following examples, we have to identify C, and then we're going to compare the value of C squared to A squared plus B squared. So let's look at an example. On example 17, 10 is the biggest number given, so that has to be the value of C. So we would compare 10 squared to 7 squared plus 9 squared. Have your calculators out for me, please. So 10 squared is 100. 7 squared plus 9 squared, you can evaluate that on your calculator. You get 130. Since 100 is less than 130, we would classify this triangle as acute. Okay, where does that come from? It comes from this relationship here. If C squared is less than the values of A squared plus B squared, the triangle is an acute triangle. All right, in part B, C again would be 10. 10 squared compared to 5 squared plus 7 squared. We get 100 again. And then 5 squared plus 7 squared would give me 74. Now we make our conclusion. 100 is greater than 74, therefore the triangle would be classified as obtuse. Let's look at one more example together. So example 18, part D. 29 has to be the value of C. 29 squared, and I'll compare that to 4.8 squared plus 28.6 squared. Again, please plug these things into your calculator. You can pause the video real quickly. 29 squared is 841. 4.8 squared plus 28.6 squared is also 841. So when the two values are equal to each other, this is a right triangle. So for your homework, please complete example 18. For the 5 remaining sets of numbers, identify C. Compare C squared to A squared plus B squared. And then draw a conclusion.